Welcome back, Geometry Scholars. Today's lesson is 2.1 Translations. Our essential question remains the same. How can you use tools of the trade or concepts to describe the construction of geometric figures? And this lesson's learning objective is that you will be able to perform translations using vectors. So let's get started. First of all, what is a vector? A vector is a quantity that has both direction and magnitude. I think of a vector as it helps determine a point in space relative to another point. So it helps tell us where a point should go. The initial point in a vector is called the starting point, which makes sense. And the terminal point is the ending point, also makes sense. Terminal usually means ending. Vectors are written in component form. I know we're used to coordinate form, but vectors are written in component form. And here's an example. We have been writing translations this way, x comma y, and then we say maybe like x plus 3, y minus 2, something along those lines. But vectors are written using component form, which looks a little bit like this. It's a v for vector, and it has this fishhook thing on top of it, equals, and we use what's called angle brackets, 2 minus 3. And you can see these numbers are the same numbers that we used over here. The 2 is obviously the x value, and the negative 3 is the y value. I'm sorry, guys, I wrote those backwards. Just paying attention. 3 comma negative 2. There we are. The 3 is the x value, and the negative 2 is the y value, in order, an ordered pair, just like we're used to. And it's convenient to describe translations using vectors, and that's what we're going to be doing today for a few problems, is simply translating figures using vectors. Something you need to know, something that's special about parallel lines, is that parallel lines have the same slope. And this is something you should be familiar with already. Just make sure we know that concept. So vectors, basically, we use a vector to translate a figure. Let's go ahead and move on to example 1. We're going to use the translation xy, x minus 9, y plus 2, to find the pre-image of b prime, negative 4, negative 11. And notice we already have b prime. We are trying to find the pre-image. So normally I give you an image, and you simply apply the translation, subtract 9 from the x, add 2 to the y, and then you have the pre-image. But this time we are trying to find the pre-image. We already have the after image, so we have to work backwards. So I have negative 4 as an x coordinate, and I would have subtracted negative 9 to find that negative 4, so I'm going to work backwards, and I have to add a 9 instead. Negative 4 plus 9 is a positive 5, so that's my x coordinate. And then negative 11 is my pre-image y coordinate, and again I need to work backwards from that positive, this positive 2, so I'm going to do a negative 2 instead. Negative 11 minus 2 is negative 13. So the coordinates of my pre-image are 5, negative 13. And then you can always check these simply by then applying the translation. So here's my translation right here, my the coordinates for the translation that they want me to do, and I can take what I think is the pre-image, my original image, apply this and see if it works out. Well, 5 minus 9 is negative 4, and sure enough, that's what I have right here. And then negative 13 plus 2 is negative 11, and sure enough, that's what I have here. So I worked backwards, and I was able to find the pre-image. So my pre-image was 513. Here's the translation that was applied to it, and then here is the after image. Okay, written in prime notation. That's example 1. That's simply working backwards. The only thing that's going to be tricky on this is making sure you read the question correctly and find the pre-image if it asks for the pre-image. So I want you to go ahead and try it. Go ahead and pause the video and try to find the pre-image of r prime. Okay, the pre-image of r prime is r5, negative 7. I took the 2, the x coordinate of r prime, added 3 because I worked backwards. The opposite of subtraction is addition. that resulted in 5, and I took the negative 8 y-coordinate of r prime, added 1 instead of subtracting 1, and I got negative 7. So the coordinates of r are 5, negative 7. Okay, moving on. How do we use vectors to perform translations? And again, that is the point of today's lesson, is being able to use vectors to slide or to move an object. So vectors tell us how many units the object or the image is moving on the x-axis and on the y-axis. So looking at this vector, and you can see this vector right here, it has an arrow, it's notated with the V in that fishhook thing. What you want to do is you want to count how many units or boxes or whatever it moves to the left or right. So 1, 2, 3, 4. So it's moving 4 units to the right. And since it's moving to the right, we know that's positive. It's going toward the positive numbers. And then it's moving up 1, 2. And again, on the y-axis, it's moving up. And so this is how many units the vector is moving. So in component form, I would write 4, comma, 2. Because that's my component form. It's moving to the right 4, and it's moving up 2. And again, this is similar to x plus 4. It's the same thing as x plus 4, y plus 2, which is the form that we've been used to. This is just another way of writing it. So this shape, ABC, needs to move along this vector. We're translating it along the vector. So we're going to move every point to the right 4 and up 2, just like this vector line did. So for example, C, and I'm going to do this in red so we can see this a little better. 1, 2, 3, and 4, and up 2. There's point C, and then I'm going to do C prime, and then B is 1, 2, 3, 4, up 2. There's B prime, and then A is 1, 2, 3, 4, up 2, and there's A prime. So think about the vector, think about the component form as just telling you the direction of where to move the points, and simply connect your points, and you've drawn a new shape. Okay, and you can see when you connect the original points to the new points, and I know that I'm drawing this on the smartboard, it's not super straight, but if I took my ruler and drew a line from A to A prime, B to B prime, and C to C prime, those would be extremely straight lines, and they would be parallel to the vector. All of these lines are parallel to the vector down at the bottom. Okay, again, I know it's not super straight, it's on the smartboard, but you get the idea. So I drew the image of ABC after a translation along V. So I just translated along the vector. I figured out how many to move up and to the right and up, and then I copied that figure down. Okay. So now we're going to find it a different way. We're going to calculate the vertices of the image figure. Then we're going to graph the pre-image and the image. The first thing I'm going to do is I'm going to simply name these points. I'm going to name them T, U, and V. And I'm going to go ahead and graph those points now. -2, 1, -3, -2, and -1, -2. So there's my T, there's my U, and there's my V. Go ahead and connect those. Okay, so the first thing I've done is I've graphed the pre-image. So I'm done there. So now I have to calculate the vertices of the image figure. So I know this is my starting point right here. I have my starting point, and now I have my vector, and it tells me which direction and how much to move. So you take the points of the pre-image, apply the vector, and you'll have your new points. So for example, T prime is what I'm looking for. So T was a -2 x coordinate, and then a 1 y coordinate. Well, my vector is 4, 5. So I'm going to add 4 to the -2, and -2 plus 4 is 2. And I'm going to add 5 to the 1. That gives me 6. So T prime is 2, 6. Okay. And here's my t. And I'm going to move over to 2, and then 6. There's t prime. Instead of adding, you simply could have counted over. You could have said t, okay, I'm going to count over 4 to the right 4 because it's positive 4, and then up 5. 1, 2, 3, 4, and then up 1, 2, 3, 4, 5. And there you go. So again, over 4, 1, 2, 3, 4, and then up 5. 1, 2, 3, 4, 5. There's my t. So you can either add or you can simply count, whatever works best for you. There's not a right or wrong way here. It's whatever strategy works best for you. So now I'm going to find u, and I'm going to find u simply, this should be t prime, my apologies, simply by counting over. So I'm at u at -3, -2, my vector is 4, 5. So I have to move over to the right 4, 1, 2, 3, 4, and up 5. 1, 2, 3, 4, 5. Here is u prime. And then v over 4, 1, 2, 3, 4, and up 5, 1, 2, 3, 4, 5. Okay? And this is v prime, and connect your dots. And again, there you have your image. So our pre-image is TUV because I named the points, and then our image is T prime, U prime, V prime. And again, if you were to take a straight edge and you were to connect, and I'm going to do this in black, if you were to connect T to T prime with a nice straight edge, and U to U prime, and V to V prime, you have parallel lines. Okay? You have parallel lines, they have the same slope. And I skipped a problem, so give me a second. Okay, last problem. We are on example 4, and this brings it all together. We're going to specify the component form of the vector that maps triangle ABC to triangle A prime, B prime, C prime. So the first thing we need to do is figure out what the vector is. So here is, write that V with the fishhook sign. And so all you have to do is simply count. Find a point on triangle ABC and count to its corresponding point on triangle A prime, B prime, C prime. So I'm going to start with B, just because B is right here. It doesn't matter which point you count, you start with. So I'm going to see how many spaces it goes, and I can tell it's going to the right, because A prime is on the, starting right here, I'm moving to the right. So I'm starting here, 1, 2, 3, 4, 5. So my, remember to use angle brackets. My x coordinate is 5. And then it's going down 1, 2, 3, 4. So in this case, it's not going up, it's going down, so it's a -4. So this is the component form that of the vector that's mapping triangle ABC to triangle A prime, B prime, C prime. That's easy enough, right? I know you guys got to count. 5 to the right, 4 down. And if you notice, what did I just make with those dotted lines and the vector? Hopefully you notice that I made a right triangle. So now we have to find the length of the vector. See this vector right here? We're finding the length of the vector. And how can we do that? We've been talking about 2 ways since the beginning of geometry of how we can find the length of a segment. One of those ways is the distance formula, which I know you guys just love doing. But the second way is the Pythagorean theorem, which is definitely a much easier way to find the distance of a hypotenuse. And you can tell by looking at this vector and by these dotted lines that I just, these dots that I just drew, that we have a right triangle. We have a leg and a leg, and then the vector is the hypotenuse. So we can use the Pythagorean theorem. Either side can be A or B, it doesn't matter. And I don't have to count again because I just counted 1, 2, 3, 4, 5, and I just wrote that right here. So to find the vector, you don't have to count 5 and 4 again because you have the numbers right here. Okay? So to find the length of this vector, all you have to do is apply the Pythagorean theorem. A squared plus B squared equals C squared. Well, A can be 5 or -4, whichever one you want. I'm going to use 5. And then B is -4 squared. And if you notice, I did put -4 in parentheses, and we remember it's because I want to square the entire -4, not just the 4. 5 squared is 25, plus -4 squared is 16, equals C squared. 41 equals C squared. And our last step is I need to apply the square root symbol because I need c all by itself. So c is the square root of 41. So that length of that vector, so the vector is the square root of 41, the length of it. The length of the vector is the square root of 41. Okay? Again, all we did was take the information we already had. We had, and if I look right here, these dotted lines, this 5 to the right, this 4 down, okay? I made a right triangle and I found this line, the length of the vector from B to B prime. So that being said, let's look down to C, finding the length of AA. Okay? Finding the length of, of AA prime. So if you're looking at your picture again, we already know the length of B to B prime, so we now are looking for the length from A to A prime. And if you think about what we just did logically, we mapped pre-image ABC to image A prime, B prime, C prime. And we already found the length of one vector. So therefore, the lengths of all the vectors are the exact same length. So A to A prime is going to be the same length as the vector from B to B prime. And the from C to C prime is going to be the exact same length as the B to B prime. So that being said, we can write that vector lengths are congruent okay? Or you can also say that when you make a segment from the pre-image to the image, the segment is congruent to the vector. So this segment from the pre-image to the image, from here to here, this line right here, I made it from the pre-image to the image. It's the same length as the vector. Okay, so just keep that in mind. It sounds a lot more complicated than it is. Do not overthink this. All we are doing is using a number to make a translation. Last thing, name a pair of parallel segments formed by vertices of the pre-image and the image. Well, if you think back, I mentioned this at the very beginning of the lesson, that all of these lines are parallel. So we would say that A prime, so this line right here from A to A prime, is parallel to B prime. Parallel to B prime. And there's another set. We could also say that A prime is, and this is the symbol for parallel right here, these two lines that are straight up and down. A prime is also parallel to C prime, or B prime is parallel to C prime. Okay? They're all the same because we are mapping from a point on a pre-image to a point on an image. They're the same length and they're parallel to each other. And as you are wrapping this up, please don't forget to write a summary. Remember, notes are not complete unless you include a summary. The summary needs to be what we've learned today. If you have any questions, write them down as well, so that way when we go over homework, you can ask me for them. Thanks, guys. Please do your best. If you have any questions, we'll discuss them in class.